Welcome, viewers, to an exciting episode of It Depends podcast. And I know I say exciting almost every single time, probably I say that, but this time it is actually very exciting because lake houses and table formats are so hot. And we have just come back from Snowflake and Databricks Summit, which were very heavy into what's the newest with Apache Iceberg, Apache Hudi, and Lakehouse, Linux Foundation, Delta Lake. So in this battle of table formats is a company, Onehouse. My guest today is the founder and CEO of Onehouse, Vinoth Chandar. Vinoth, so great to see you join us.
Hey, Sanjeev, great to be on the podcast, and it's actually so awesome that we get to do something together, having kind of known each other for like on and off for a few years now.
Yeah.
So yeah, great to be here.
Yes, and also today is a momentous day, and why I say this is because One House announced their Series B funding of $35 million. Congratulations, Vinod. That's such an achievement in a market like this with such economic headwinds. That is quite an achievement.
Yeah, I mean, we're really thankful, thanks for that, and really thankful for the trust that our investors have placed in us. And I think this we're really excited with this round. We are also, kind of bringing Craft Ventures on board to our board with. They bring a lot of the SaaS DNA that's needed as we kind of embark on a growth journey in the coming years. So it's a really exciting time to kind of build more and also
Hmm.
push into the market. So super pumped for what's ahead.
So what you've got three investors, right? Kraft, Greylock.
Craft, yeah. So Greylock and Addition, they've led the seed in the A before,
I see.
and I think for this round, and as you know, Greylock has needs no introduction, but Addition as well is created by Lee Fixel, who's like legendary for running Tiger Global for so many years
Oh,
and
wow.
sort of like overseeing so many unicorns out there. So they've seen like a lot of these iconic companies.
Hmm.
But the one thing that we wanted to get was, end of the day, we're building a cloud SaaS product. So
Hmm.
having Craft with their kind of specialization around SaaS, and they've kind of helped on the GTM efforts for many of these companies. So getting them on board now gets a different, it's a really awesome board with a lot of firepower to kind of take on the challenges ahead. So I'm super excited for that.
Very nice. I know Craft Ventures, I know about them because I listened to the All In podcast and David Sachs is the founder. He's one of the four besties on All In and the founder of Craft Ventures. So so that's how I know about him. With that, let's get started. Let's start with an introduction. You've gone through quite an amazing journey in the past. Can you please bring us up to date on what has been your work and your background up to this point?
Yeah, sounds good. So obviously, right now, I my life is dedicated to one house, I guess. So on data lake houses. But before this, I was a principal engineer at Confluent, working on broadly across like stream processing, KSQL DB,
Hmm.
Streams Connect, and even like the guts of Kafka and understanding, what cloud native next story should look like. I left Confluent as soon as I got my I was able to actually go legally start a company. And before that, I was principal engineer at Uber for almost 5 years. It was I was among the first 200 engineers at Uber, so had an interesting ride. Seeing all the hyper growth and all
Hmm.
the interesting there's a very interesting journey, and got to build a ton. That's obviously where we created the world's first like data lake house, if you will, but we call it a transactional data lake. But then, that's where Hudi was born, and then we continue to kind of open source project, and I'm pretty sure we'll talk about it a lot more.
Yes.
Before that, key value stores at LinkedIn. I was a tech lead for this project called Waldemar back in the
Hmm.
day at LinkedIn, Dynamo style key value store during an era when everybody were building key value stores on-prem. unlike today's world, you have to build stuff on-prem and operate it on your own. So that taught me a lot about building, kind of like data platforms that the entire company and like, a lot millions of users kind of depend on. So I thank Lincoln for that experience. And I started my career at Oracle, working on Streams, Extreme, Golden Gate, the data replication product.
Oh,
So
wow.
that gave me like I guess there is CQL and stream processing before stream processing. So being like, kind of fortunate to have worked on, I think, these systems over the years.
Yeah, because Oracle Golden Gate was one of the original stream processing products. Like even Stream, STRIIM has its own stream processor, which is like we talk of them as change data capture products, but they're actually event stream processing engines. And now, of course, it's Flink. Flink has taken over completely, and that is the de facto standard. But we are not talking today about stream processing. We will leave that for another time. Let's go back to your Uber days. What was the
Mhm.
problem that led to the creation of Hudi?
Yeah, great question. So this was Uber, 2015, 2016, growing 4x year over year. And, we had started our stack with a data warehouse. We were on-prem, and we had an on-prem data warehouse. And we brought in a Hadoop data lake to kind of like deal with the event stream data and the high scale data that cannot fit on a warehouse, right? But we found ourselves in this kind of pickle where the data warehouse had transactions updates, and it couldn't scale a lot, but it had that functionality. But the data lakehouse, we could run like Yarn and Hadoop and scale storage and compute elastically, but it was super inefficient, right? We had to like do a lot of file management, rewrite data over and over again. We had to do batch jobs which will crunch very large tables every 8 hours, 6 hours. This just didn't fly in a company like Uber, where it's actually, if it rains, traffic, weather pattern changes, then search goes up, a lot more people take Uber, and then pricing changes. So we need everything near real time. Right. So our options were, well, move everything to streaming. That is cost prohibitive. We can't run the entire thing in fully real time, kind of row oriented processing, right? So we looked at other systems out there as well, and then we finally decided, okay, we really like what the lake has around compute scaling and data scaling. It basically lacks these kind of transactional kind of abstractions on top and these primitives. So why not add these on top as a library, and we called it the transactional data lake, a term that I think AWS uses to date, and that's kind of like how Hudi was born. And a lot of the functionalities, including the things that we talk about, right, indexes, file sizing, these were in like V1 of Hudi, because we had to run it across 6,000, 8,000 tables across 3 engines. Hive, Presto, and Spark, and later we added Flink and like other engines as well, right? So we would say that this whole like headless architecture, if you will, around on-demand compute coming up, writing like committing a transaction to a table, and then on-demand like readers can come up, query the table. This whole model was born out of that need. So it was multi-engine and open and like kind of platformized from day one. Then we open source a project as early as 2017. So we were the earliest open source Lakehouse tech, if you will. It was on Uber's GitHub for like a year and a half with the early adopters and all of that. Some of these early companies kind of expressed that, oh, we should move this. This is a storage project, so let's move it into a more central governance. So Uber donated the project to Apache Software Foundation, and in 2019, and a lot of cloud providers, Tencent, Alibaba, AWS, all of them kind of came into the project. They still sit on the PMC. They are drive 2019, Hudi was integrated into EMR, later Athena, Redshift, and all these different services. So that's kind of like how this whole journey unfolded. The thing I would call out is when what we built at Uber was like an incremental data processing library, and with like a storage format that was very optimized for that. in the community, though, it's taken a life on its own. So it has like way more engine integrations. People have built like platform services that do way more upper level functionality, like data
I see.
ingestion, data transformation.
Mm.
So Hudi is now the best way to characterize Hudi would be like an open Lakehouse platform, or
Mhm.
data lake platform. Yeah,
And
it's been a
it's an acronym, right? What does Hudi stand for?
yeah, it goes back to the roots of the problem that we were solving back then, which was, sort of like Hadoop, upsert, delete, and incrementals.
Right.
So what we needed to do first cut was there was this database that stores all of the trips and transactions at Uber.
Yeah.
We needed to kind of, upsert those change records into like on top of HDFS, and
Yeah.
then build incremental change streams out of it to further more like incremental ETL pipelines. So that's kind of like, that's where the name started. And I guess like much like GPUs, it does way more things today, even
Yeah.
though, the name's the name.
So what really amazes me is that while Uber was working through these problems, Netflix at almost
Hmm.
exactly the same time was having its own problems with providing transactional semantics on top of a data lake. So Apache Iceberg was born out of the work at Netflix and Apple. And then at Databricks, Delta Lake was created all around the same time. So now we've got not one, not two, we've got three table formats. So before we talk about other topics like interoperability, I want to understand how should we think about these three table formats? How are they different, and what use cases would I use each one for?
Yeah, great question, right? So one, I think this whole table format, the term itself is like a very iceberg centric kind of term,
Okay.
right? If you look at generally how Delta or Hudi present the projects, it's more like like Delta, I think used to call itself the transactional layer for
Hmm.
like data lake houses, and we've always called this like a open, either an incremental data processing framework or like an open lakehouse platform as we generalize the use case more. So, end of the day, I would say there is a common denominator, right? So, Iceberg focuses a lot more on the like the table format component, which is essentially a way for you to organize Parquet files and some metadata associated with that clearly distinguishes table snapshots and like other metadata around the table, right? So there are similarities and differences across them, but the great thing is all of them store data in Parquet, right? So this is, so a lot of people confuse this with the Parquet versus ORC kind of
Yeah.
thing. That's I think also again, like recently of these two conferences and having spoken to some 1,200 people in our booth, this is one thing that we kind of across both. So that we realized was even Parquet versus Iceberg is very confusing to many people, right?
Hmm.
So end of the day, this is not Parquet versus ORC, because you cannot write as Parquet and read as ORC, for example, right? These are file formats,
Hmm.
right? These are table metadata formats,
Hmm.
right? And then starting at that layer, I would say Iceberg has a more like a snapshot based approach. So it provides like entire file snapshots, which is, I guess, much easier to integrate for engines like warehouses. While Delta and Hudi both have like a log based representation for the metadata, this allows for you to scale with like more frequent writes, because every write you're not rewriting the entire table's metadata. But obviously there's more involvement needed for an engine to integrate with Delta or Hudi, because they need to parse this like metadata log and construct the latest snapshot, like so there are some differences like that. When it comes to the actual use cases, right? I think where the differences are, I would say there are a lot more upper level functionality needed on top of the table format to build end-to-end use cases, right? So if you are, this broadly falls into data pipelines which are writing data,
Yeah.
queries which are reading data, and table management functionality. So across these three,
Hmm.
if you compare the three projects on writing, I think Hudi is a lot more optimized for kind of mutable workloads because it has an indexing subsystem. It can do things like async compaction, where it can compact and do table services without blocking the writer, right? We really, for example, you cannot really stop the writer and take it offline to do table management when, let's say, ByteDance, TikTok, or they're ingesting 15 GB per second, right? You'll just like fall behind, right? So it has like different kind of coordination protocols and indexing, so and these things to make that happen. While Delta, I think I would say they have a really good deep integration with Spark, where they can tap into the Spark machinery to kind of optimize the write path and all of those things, right? So here I think Iceberg leaves a lot of this to the user, so you can go tune and kind of control the file sizes and all of those things. These kind of things come out and kind of like benchmarks that people have otherwise written as well, right? And so essentially incremental writes is something like Hudi is optimized for, and it's kind of like, where it's differentiated. Delta is somewhere in between, I would say. And when it comes to table management functionality, that's where I think, again, Hudi has built-in table management. So, and a lot of people we've seen that don't even realize it. So you do a write in Hudi, it will automatically size files for you. If it is let's say a merge and read table, it's going to do compaction, cleaning. It's going to do like these 4 or 5 bookkeeping tasks that it needs to do to maintain that table automatically. And this was a design choice that we had even for the very first of Hudi, because we had to run 4,000 of these, right? And we don't want to sit and do that. And I think where I would say the differences are in the upper layer functionality. And there are some differences in terms of how the metadata itself is organized, whether it's read optimized or write optimized.
So you mentioned in case of Hudi, you mentioned a term merge on read. So there are 2 options: copy on write, merge on read.
Yeah.
Can you explain, because Iceberg does copy on write, which from my understanding is that if, let's say, the schema and the source were to change, like, you renamed a column or something like that, in Iceberg, it's copy on write. So when that write happens, you make a copy of the Parquet file.
Yeah, so it's more to do with like record changes, and I'm happy to go deeper into it. So these 2 terms are 2 terms that we kind of originated in the Hudi community that have become like how industry reasons with read write trade-off. So it's essentially about when you're updating something, are you absorbing the cost on the write side or the read side? That's fundamentally what these 2 mean.
Correct.
Right? People have told me that I should have called copy on write, merge on write. Essentially, here's the problem. Just generically thinking across, right? You have a large set of Parquet files and you want to change a few records. So what copy on write does is pretty much it somehow figures out these are the files that contain the records that I'm trying to update, and it simply copies the Parquet file over and just like updates the one record. For example, you have your Parquet file had 1,000 records and you want to change one record. It's going to just copy over 999 records and write the new value for the one record, right? That's so you absorb all of the cost on the right side. As you know, writing Parquet columnar formats is like orders of magnitude more expensive than, let's say, writing Avro or like row-based formats, right? So, but the great thing about copy on write is like the readers don't have to do any extra work. They are just operating on Parquet columnar files. So 0 read amplification, maximum write amplification depending on your workload. That's what copy on write is. Merge on read is a lot more flexible. So you essentially for Hudi, what we do is we write row oriented data. So once you figure out, okay, this is the record, this is the file, Parquet file that needs to be updated, instead of rewriting the file then and there, we keep queuing up these updates
like a log,
a
transaction
like
log.
a log.
Right.
Yeah.
Okay.
So yeah, exactly. So think of the Parquet file as a database checkpoint, and this is the transaction log. Yeah. So you queue up the updates or deletes basically against the Parquet file. When enough of them build, you amortize the cost of writing the Parquet file. That is essentially what this background compaction process does. So your writer keeps writing. and this can be columnar or row-based format. So it's very flexible. So you can choose how frequently you want to compact. You can choose to, for example, compact the recent data more aggressively. So you get columnar performance on that, while you kind of, compact. So a lot of these systems get late arriving up deletes and updates. So you can choose to compact them, let's say, like every few hours, right? So that significantly lowers your cost of actually merging data. So this is what merge on read is. It's significantly more. It's very flexible, but it also needs to be used with with the understanding of your write patterns and your read patterns. So that's why it's a little bit more
So,
nuanced, right?
so to summarize, copy and write is done by all three formats, but merge on read is done mainly by Hudi and Delta.
No, actually, no. So Iceberg V2 format lets
I see.
you again encode what they call push null deletes, and they have something called equality deletes as well.
I see.
So Iceberg lets you encode that in the V2 format, I think.
Hmm.
But there are design differences across all three, which are still significant when it comes to how MOR is implemented. So very specifically, Iceberg turns like an update into a delete and an insert. So
Hmm.
what they do is they write what's called delete files, which essentially say, okay, here is the Parquet file that you're trying to update. Instead of writing like a log file or anything, they're basically saying they write a special file which says these record positions here are deleted.
Hmm.
And we support these delete positions in our log format as well. But essentially, but and then write the inserts into like new Parquet files,
I see. Got it.
right? So this is okay, and Delta does something very similar, but Delta's design is a little bit more closer to Hudi in a sense that it associates those. So in Iceberg, this deletion files can have pointers to any number of Parquet files,
Hmm.
which means when you're trying to kind of compact them, you need to kind of do a little bit of a graph coloring problem to figure out how to compact them efficiently, right? But I think again, this is like the philosophical difference. I think the Iceberg design is more around, okay, you could you could encode it this way, right? But Delta and Hudi focus a lot more on how to efficiently implement that. So both Delta and Hudi associate deletes with a particular Parquet file. Or that means what happens is on the query side, when you're reading Parquet and you're applying these updates or deletes to it, you are bounded. The amount of data that you scan is pretty bounded, as opposed to for every base file, if you scan every other log file, other files out there, your read costs are going to just exponentially increase because it's increasing with the number of files you have in the table, right? So
Hmm.
Hudi and Delta, I think, as I understand Delta's design as well, um, it bounds the merging to a single, what we call a file group in Hudi. And I don't know if they have an equivalent term in Delta.
Okay.
So anyway, Hudi's design has been around. Hudi has had merge and read for since 2018, like 2018 or 2019, right? This was being one of the more debated things. I don't think many engines support Iceberg V2 yet in terms of merge and read. So all in all, when you hear, for example, people say, "Oh, Hudi is like great at these streaming workloads or incremental workloads and all of this," much of this comes from this like merge and read design that
Hmm.
we've had for like 5 years now in open source.
So let's talk about Databricks is buying Tabular. This was announced a couple of weeks ago.
Yeah.
What is the impact of that, and what happens to because now Databricks has ownership of kind of ownership is a loosely used word, but they've got Delta, which they completely own, and now they've got Iceberg. So do you see them merging, or what are your thoughts?
Yeah, great question. And again, like I'll first preface it by saying, like everybody else, I know what was announced on the stage at Data AI Summit. I'm gonna share my opinions or guesses, and like because I
Yeah.
think we're all in this prediction game, so I'm going to predict as well. So my take is so overall, more in the basically they say is they're going to make it more compatible, more interrupt them, more better. I think generally speaking, moving the industry in that direction is great, right? And I think for us, having made some of those first moves with one table, XTable, and all of that, we really like that. The sound of that, Delta and Iceberg being more compatible. So, but we don't know what exactly it's going to look like, right? Are we going to make Delta look more like Iceberg, or Iceberg looks more like, we don't know. I'm pretty sure the teams are figuring out what this is, right? But
Yeah.
I doubt Delta Lake is going anywhere, right? Because people are writing, and for a couple of reasons. One, people are writing exabytes on it today based on what Databricks shared, right? And there are tons of features built inside Databricks around Delta Lake, right? So my guess here is, and it's aligned with the strengths of the projects. So Iceberg could become that standard interop format for table metadata. I can pass and explain what I mean by that. But essentially, if you look at it, there's Parquet, right? The data, most of the data is in Parquet. And there are differences around, let's say, how MO or deletion vectors or delete files are written, or log blocks are written even across Hudi, right? Maybe we standardize Delta, standardize a few things around that, and have Iceberg be more of the high, the high format replacement, if you will. While Delta and Hudi both have richer features on top of the table format, right? For example, Hudi has indexing subsystem. Delta has like liquid clustering, right? So Delta and Hudi are more full-fledged data lakehouse kind of systems where you can take and read, write, and production data pipelines on top. So that could be one way in which this could go.
So liquid clustering is automated workload
Right.
optimization.
And that plays to, yes. So liquid clustering, and we call it incremental clustering in Hudi. So it's essentially as you write data into a table, right? Let's say you want to ingest quickly, you will be forced to write small files. So small files fundamentally affect query performance. So there needs to be a system which can amortize enough of the cost of rewriting these Parquet files against the cost of querying small files and all of that. So see, these are actually database problems that need to be solved on top of the table format, right? And that is generally where, at least from the Hudi standpoint, that is basically where Delta and Hudi have competed over the years, right? So Iceberg's been, focus has been more around, we're going to bring like some standardization around how we represent a table. So my guess is maybe this is the direction that we go. And by the way, Snowflake uses Iceberg in the exact same way, right? So all of the metadata in Snowflake lives in Foundation DB, right? So when you're writing a managed Iceberg table, this is based on at least whatever YouTube video that I saw about the design. You write, instead of writing their proprietary file format, they write Parquet. They commit those files into their own metadata layer. Then you produce an Iceberg snapshot consistent with that transaction boundary, right? So if you think from those standpoint, Delta having its own metadata, Hudi having its own metadata, and then doing like that's exactly what XTable does today by producing another Iceberg manifest, right? So maybe Iceberg place becomes like more around that strength that they have around interoperability and like a standard representation for table, while Delta and for us on Hudi, obviously as well, will continue on investing on the upper level functionality, because we fundamentally believe we need open compute services as well, not just the format for users. So it's a different, we diverge there, I feel.
So this is a challenge we have in our industry, which is that on surface, we talk about things as if they are like different types or different options on the for the same functionality. But when you start digging deeper, you find out that they're very different. You've been talking about interoperability, and you mentioned XTable. Databricks has something called UniForm. So that interoperability is a very loaded word, because what you're saying really is that you can use XTable and you can translate between different table formats for read-only purpose. But the writes will always be different, right? Because the way they're writing is very specific to that format.
Yeah, makes sense. Yes, you have read compatibility, if you will, but writer compatibility that fundamentally touches on the commit, right? Even across Delta or Iceberg, if you want to unify, you have to either write the manifest file, that's the source of truth, or you're writing the Delta log, right? You can't write two things, then it's not transactional, right? So so there's a choice to be made there. And I think in this, again, it'll all become more clearer down the line when we actually know what a Delta berg looks like, right? But I think this is kind of touches upon the fundamental concurrency control and how everything else is done. So it's open-ended, at least, to say the least, right?
So to explain how this interoperability works, so please help me fill in the blanks here. So if you have something like Microsoft Fabric, which uses one lake as its underlying storage subsystem, which is based on Delta Lake format. So anything that's written, the writer will always write in the Delta format. But then XTable, which comes from your company Onehouse, which is an Apache incubating project, you will then take that Delta, that log, what was written, and you will create an Iceberg manifest file and a Hudi file to provide read compatibility. Is that correct?
Yeah, that's fairly accurate. I would also correct that a little bit. We don't want to we won't take full credit for XTable. So we did one table, which then Google and Microsoft extended these things. So this is it's like Apache XTable is like an open source project that is kind of like has many more folks at the table than us and centrally governed and incubating. So just wanted to kind of correct that for our audience there.
Okay.
But yeah, absolutely right. So and also the reverse way. So the announcement at Build, I think last month was if you write through Snowflake as Iceberg tables, the reverse happens. You have Parquet files with some Iceberg metadata, right? There's a service in Fabric. I don't know exactly how it's implemented myself. It basically translates the Iceberg metadata into like Delta metadata. So like all of the rest of the Fabric ecosystem, which is probably optimized to read Delta, can now like read this metadata and then like plan queries and kind of like move on, right? So I think and end of the day, this is the main thing, right? So before we build one table, we announced one table at Onehouse that I think we would like to take a tiny bit of credit for. Maybe we were talking as if this table formats were like Parquet and ORC, right? We basically now shown at like industry scale that no, this is not the right thing. It's not good to build these silos again around table formats, right? We just took like a decade to move us from proprietary file formats that Barrows was writing to kind of like Parquet. We just like agreed on one thing, right? So we shouldn't again go back into silos based on table formats. It's one of the main core reasons that we built this interoperability thing. And now there is like two, right? There's like XTable and then like UniForm. But the great thing here is we work, we collaborate pretty well. So we actually helped share code. We helped actually build the Hudi support in UniForm. There's even a joint blog on Delta Lake. So my take on this would be ideally we have XTable we've established a project with central governance, and XTable does does 6-way translations. What we call, you can go from any writer to any reader, as opposed to UniForm. Today, at least, you go from Delta to Hudi and Iceberg, right? XTable can go from like Hudi to other two, Iceberg to other two, and so on, right? So maybe have UniForm be built on top of XTable. That way, it also gets the job done for Delta Lake users, while we have like a single piece of code on this like format translation that all the vendors across the aisle are committing to maintain and not fracture for the users, right? So the main goal here has to be, it's not our data, speaking as a vendor, it's the user customer's data. We should do right by them and make sure this data doesn't get fractured into a silo because of that's a slippery slope. So this is my preference. Let's see what happens.
Okay, so what you're saying is that UniForm by itself today will only write in Delta, but then you can read it as Hudi or Iceberg. But with XTable, you can write in whatever native format that tool has. It could be Iceberg, Hudi, Delta, and then it converts to the other remaining two formats. So, got it.
Exactly. And there are like concrete use cases for this today. For example, there are like, as you know, like EMR, there is like lots and lots and lots of users been there who's built, a lot of these incremental data pipelines and these Spark jobs, right? So for them, they can use XTable to get like Iceberg tables in Athena to be queried, right? So stuff like that. So our have maybe like Google BigQuery, right? Iceberg tables, which then Hudi can build indexes on top for, we have some like large GCP users. So Hudi has indexing, record level indexes that it can build to accelerate Spark queries. So those kinds of functionality can be built on data that is written by BigQuery. So this is actually a really great thing. We are actually able to map the right the superpowers on the writing side with the query engine integrations that exist on the reader side. So I'm super happy that it has come this far.
This is great. Since you're doing such a deep dive into the differences between different formats, can we just talk for a few minutes about permissions? Because it turns out from what I learned recently was that Iceberg specification does not mention how to do any fine-grained access control. I don't know how it's in Hudi and Delta. So you can only do, if you have Iceberg, you can only do coarse grain, which is at the table level, but not at row level, column level.
Yeah, you touched upon a really great point, and some of this is like an open debate as well. So traditionally, if you look at it, you had Parquet, and these three projects solve the need for organizing Parquet-based data lakes better and tracking some metadata on top, right? So actually, going all the way back to when the times of you writing Hudi, I actually wanted this problem to be solved in the Hive metastore. The Hive metastore holding file level column statistics, for example, would have been the right way for us to approach this. So it was like always the statistics and metadata is a catalog problem, in my opinion. But unfortunately, Hive metastore hasn't like been able to kind of like evolve with them and like
They have
become
Apache
that.
Ranger, right? Apache Ranger does that?
Yeah, so there are two kinds of APIs. So one in when you look at this technical catalog. So one is the APIs around actual technical table metadata. This is like, okay, what files exist in this table? What snapshots exist in this table? For this file, for this column, give me statistics on min, max, distinct, blah, 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 right? So that is one set of APIs. And maybe there is another right set on the same group, there is writer APIs where you say, okay, to this table, now add these new files or remove these new files, right? The second set of APIs are around access control. That is basically where like Ranger comes in. There is a mix of functionality between something like Ranger and also Hive metastore, right? So this access, so what I'm trying to get at is if you look at any modern data warehouse, their catalogs do a great job at both. This is what the foundation DB layer does for Snowflake. It kind of indexes all the statistics, so you can have billions and billions of files. It's a database query to say, select star from this metadata table where file ranges for this column are greater than less than the predicate, right? So you'll get a milliseconds of response back. That and the faster this catalog and this technical metadata can be, your better plans you can generate, right? So the whole game around plan generation is the more access you have to data at runtime, the better plans you can generate, right? So this is basically what this game is. The access control is like a relatively more self-contained problem. And so as we evolve in the table format, the catalogs have been doing this. So today, if you take, for example, like the Hudi ecosystem, you can enforce these access control policies on Hive metastore using Ranger, and Hudi will play well with it because Hudi is just like another table. This is like a layer higher than the table format, right? Similar with Glue data catalog, BigQuery catalog, Big Lake catalog, any real like engine catalog out there. You can go manage permissions there, and these table formats will play along, right? Now, the conversation is, we now have technical metadata around query planning in table formats. Access control is still in catalog, right? Hive metastore hasn't really caught up to either. So now what's the new industry standard for the catalog? How does that look like? And are everybody going to, like, this needs engine vendors to come in and like kind of commit to implementing that new open
Yeah.
common standard. So
Yeah.
what are we going to implement? That's the conversation that's going on.
So we are now going in this direction of catalogs. So you've mentioned Foundation DB is the database management system which is used inside of Snowflake. It's not really exposed to the outside world, but the metadata, table metadata, statistics and min-max, all that is stored there. But now they have also announced Polaris, which will go
Yeah.
open source in a few months. Unity Catalog also became open source. Then you've got existing ones other than Hive Metastore. You've got like AWS Glue, for instance. So, what is the role of these technical Metastore? They're not catalogs like
Yeah.
Polaris,
Yeah.
Glue, and Unity.
Yeah, I'm really happy that you drew that distinction. So yes, this is Metastore functionality, which is more about query planning and all of that, right?
Mm.
So okay, but Unity Catalog does have catalog functionality as well. Like you can
Yes,
attach permissions, so you
Unity
can do.
is unified. Yes, Unity has a
Yeah.
lot more. Also, concurrency. Are these catalogs the point where the concurrency is managed, so you don't have two people writing to this.
Yeah. Okay, awesome. So I really love this conversation. You're touching on some really, really deep topics here. So let's go one by one. So Polaris seems like, based on the announcement, seems like a REST Iceberg REST catalog implementation, right? Which is kind of like an open catalog specific to what the Iceberg REST catalog API would be. It's kind of like I think remember I talked about the two APIs, the
Yes.
technique, the Metastore APIs around query planning and writing, and the
Access control.
access control ones. The access control ones can be done in an easy way across the three table formats, if you will. Right, that's what Unity Catalog already does. It has support for all three projects using UniForm to translate Delta Iceberg, sorry, like Hudi Iceberg into a Delta table, and you can then attach permissions on top of it. So at least it's enforced on the reader side, right?
Okay.
But Unity also supports now the Iceberg REST Catalog API for Iceberg users, and HMS protocol ready for people using HMS. Right, we have a version called the Hudi Metastore, which is essentially supports Hive Metastore, like HMS compatible protocol, with some extensions on like Hudi specific metadata, right? So I think if everybody comes together and designs like a more general, version, general purpose common set of APIs for technical metadata, right? And maybe we can't fully unify the write APIs, the commit APIs, that's okay. But things like, okay, here's a table, give me some snapshots. Yeah, what are the statistics for these files? And those there's a good amount of common ground that can be covered, and then implement that on top of like these open source projects as well as these proprietary catalogs. I think that would be like a good place to be. The one distinction I would draw is like I want to see if people who are like Polaris or Snowflake or Databricks, basically they want to go turn Unity or Polaris, one of these things, into a production grade replacement for Hive Metastore, right? It's not, and so it's one thing to build a reference server for people to use in open source, but there are like, as you know, like tons and tons of companies who do like in production Hive plus Ranger or that kind of, you need a production hardened deployment. There's a serious need for something like that, like a production gate replacement for Hive Metastore. If that happens on top of this new common API, that will be ideal. This is my wish list for what I hope happens here. On concurrency, it's a great point. See, right now we talk a lot about, especially around Iceberg, we talk a lot about, okay, this you see these block diagrams where you say like Iceberg and the read, write, everybody can read, write. But today you cannot, right? Because there is one writer and everybody can read, which is still like really good from where we were before. For that, at a table level, everybody needs to agree on what the catalog is. So for example, if I'm writing from, let's say, Dremio and Snowflake into the same Iceberg table, Dremio somehow needs to know that, oh, for this table, Snowflake is the catalog, not me.
Mm.
Otherwise, what happens is Dremio will take its own lock in its own catalog. Snowflake is going to take its own log in its own catalog, and then they're going to end up correcting the table,
Oh my God.
right?
Wow. Yes.
So this needs a level of cooperation and collaboration between vendors that has been unprecedented, because
Mm.
these catalogs are also very deeply entrenched in, query planning execution paths, right? So having, let's say, for example, like a engine vendor A making a call out to engine vendor B's catalog at runtime to coordinate a write, it can be done, but think about it, like then that catalog needs to be in the same zone or availability zone and region as
Mhm.
you're operating to avoid latency issues. Practically, when you go into engineering this, there's so many challenges here that like that have to be solved to for us to reach that kind of nirvana state, right?
Yeah.
So right now the model is kind of you pick a writer, you pick the management on that, thanks to XTable, UniForm, or this catalog syncing that we have and all of that, you have read across the board, right? So pick a writer, you can still access it from everywhere, the data from everywhere. That works today. And I'm curious to see how everybody comes together and to solve some of these problems. We are not a warehouse or an engine vendor. Like we are a data vendor at Onehouse. That's how we look at it. We focus on making your data open, interoperable, managing it independent of these, without much like deep lock in to any one engine.
Mm.
So we are also, you know, curious, and like we are
Yeah.
participating in all these
So
conversations.
I really appreciate your candor and making us understand the complexities that are involved in this whole table format or transactional capabilities over Lakehouse. So I want to ask you, so now that you have your funding that got announced today, what's on your roadmap?
Yeah. So at Onehouse, maybe I'll start with the overall mission, right?
Hmm.
So
Yeah.
we started this company around. I think I would say boil it down to two key things. One, having been with the data lakehouse in this journey from day one. We had like years of companies building data lakehouses by building their own teams and in taking on projects that took like 6 months to a year to complete, right? While on the other side, you can click a few buttons and 5 times Snowflake, you can get your thing built. So we wanted to change that. So we want to bring not just great technology, but like ease of use to building data lakehouses. That's how we believe data lakehouses will become the de facto starting point for anybody who wants to build a cloud data lake platform, right?
Yeah.
The second mission that we have is the way in which we achieve that. The way we want to do that is we want to be multi-engine, multi-cloud, and have data be open, interoperable, not tied to any one engine. We support, for example, syncs to multiple catalogs, and we want to be able to one day translate permissions across these catalogs as well in a way that you can bring a new engine if you want
Mm.
to without sacrificing all your permissions and security that you already have, right? So so we are, I think right now we are the only multi-engine, multi-cloud, like pure play data lakehouse out there. It's very idealistic vision, right? But here is how we sweeten the deal for customers out there to kind of maybe like eat their broccoli, maybe, is to say we have the best, the most industry leading efficient data ingestion, and we have the broadest selection of query engines that can sit on top of us. We have the most cost efficient incremental ETL pipelines that we offer, and we also manage data centrally. So this is generally what we do. We are the bottom half of
Okay.
your warehouse, lakehouse, if you will.
Okay.
And
And
for
you
yeah,
announced two products, right? What are those two
yeah.
products you announced?
Yeah, so on top of this managed platform, we've been talking to customers, and then there've been two specific pain points that been unearthed, right? The first product is called Lakeview. So a lot
Lakeview.
of people are, which is an observability product for the
Mhm.
Lakehouse. It's a free tool that we offer to the Apache Hudi open source community right now. And thanks to XTable, I think we'll eventually translate the metadata and extend it to Iceberg and Delta Lake as well. So we see a lot of users wanting to like build lakehouses, but they don't fully understand that you need to spend a lot of time optimizing these tables and getting your layouts and all of these things right for you to have superior or comparable performance against your warehouse, right? So this product essentially is a thing like, provides insights, observability, at the storage level to say read write patterns, file sizes, so is your partitioning right, and these kinds of things. Sends you some weekly emails and stuff, so we can like also it's not a point in time. So we've kind of poured our understanding of these workloads and our expertise into this product. Hopefully that helps the community do open source kind of better, and also helps us support the community better. That's the first product, Lakeview. And I think the second product is called Onehouse Table Optimizer. So the biggest thing that we heard from the Hudi user base is a lot of them have built, Hudi's been around for a while, like a lot of them have built solid production pipelines. They've written Spark jobs, Flink jobs with business logic to kind of like, process certain use cases, right? So they're not necessarily looking to kind of like, rip and replace and migrate these pipelines over, but they do see a need for advanced table management that their engineers necessarily don't want to go into. So all these things around like liquid clustering or the incremental clustering that we talked about, or kind of if you want to index a particular column, there's an indexing service that we can build the indexes and manage them behind the scenes, like things around catalog syncing and all of those other things, right? So they want to own the business logic in their data pipelines while using us for the optimization and management. So that's what the table optimizer does. It's also a good example for you can use an existing open source technology and it seamlessly interplays with a managed service like Onehouse, right? So that's another product that we're launching.
Right. And so Lakeview is free. Table Optimizer is a commercial product. How do you monetize in Onehouse? What's your pricing?
Yeah. So broadly speaking, we are very opinionated about open data formats, right? I mean, there is this, we don't make money off of table formats or actual open storage formats. There is no, for example, like proprietary format and open format. But we do offer managed compute services for data ingestion, data transformation, catalog management, and table management that you can buy from Onehouse. And the principle that we have around this is most of these services they're also present in Apache Hudi as compute services on the Lakehouse platform. So it's your call. So you as a user, you can either build using that as a toolkit or buy us as a managed service. As a managed service, we are able to do certain things like workload specific optimizations. We can automatically learn your write patterns and apply the right indexes, for example. So these kinds of things that we are able to do in a managed service, which is very difficult to deliver in an open source library.
So Vinoth, I have almost an hour-long set of questions to ask you, but we are running out of time. So let me ask you a burning question. We haven't even talked about AI at all in this, which is refreshing. But what is the metadata support for unstructured data?
Great question. So unstructured data is an interesting conversation, and I think we're going to see a lot more of unstructured data and lakehouses in the future. All of the Lakehouse work so far has been around structured data to match like data warehouse functionality, right? So I think broadly speaking, for Hudi, we are investing in better blob support, starting with looking at whether there are like new file formats that are needed. Like this is your typical inline blob, out of line blob kind of functionality that is needed at the storage layer. Better indexes, and to be able to, for example, text search indexes, vector search indexes on top of this data to be able to like query your data, like multi-model data. How are you able to query? And you can already see some moves like Delta Lake, I think recently announced a semi-structured data type. I forget the exact name.
Open variant.
So, open variant, yeah. So you're going to see, and there are like new file formats that are especially for blobs. You're going to see a lot of action around this. And that's very exciting for us because it'll be good to unify, bring the management layer that we have that we done for the structured data, the same kind of principles, if we can bring to unstructured data management as well, that's going to be like very, very cool, I think.
That is absolutely fantastic. This we can go on for a long time. Just in the last 1 minute, what are your views on open source versus closed source?
Great question. So I feel closed source, I mean, everybody builds closed source. We build closed source as well. I feel like as long as there is open source equivalents that are not, crippling to organizations that are building on your thing, I think I'm fine. I'll give you a great example, like the Spark ecosystem. You can either use Apache Spark or EMR, Dataproc, Fabric, or Databricks. Like you have that option, right? So I think, and also speaks to the fact that open source compute should deserve a lot of conversation as well. Compute lock-in is very real. We talk a lot about data lock-in. So that's kind of where we stand. That is also why we have emphasize on open compute services in Hudi as opposed to just being like a table format layer. Right?
Got it. Thank you so much. This has been such an amazing episode where we really geeked it out. So I hope the viewers actually like it because this is like pretty deep technical, but I really, really appreciate. Thank you for coming to this, to the podcast. It's been a pleasure talking to you. Thanks,
All right.
everyone. Till next time. See you. Bye.